faces the year 2150, a future even more incredible than what has been depicted in science fiction. Picture a world where people live through genetic engineering and nanorobotics for centuries, exchange information via digital telepathy, and manipulate the climate unimaginably. Imagine space elevators traveling through space like cars, taking their passengers to work while artificial intelligence controls our daily lives. The integration of man and machine is now a reality. The line between fact and fiction is blurred. Let's start a mesmerizing 20-minute drive to discover 5 unbelievable achievements humanity will accomplish in the next century. Get ready to be amazed and begin our exciting journey now. From an AI perspective, the 22nd century remains a realm of speculation. AI can potentially steer humanity toward a utopian or a dystopian society. Only time will reveal the outcome. Well, it is pretty clear that artificial general intelligence is not far away, and futurists say it is less than a decade closer. Once AI general intelligence is achieved, it will revolutionize every field, from science to the arts, medical science, economy, and weather predictions, and it will ultimately outperform humans in every domain. But can you imagine the possibility that autonomous artificial superintelligence will completely take over human society and govern it, possibly in a benevolent way? As we see the current progress in AI, it becomes clear that in the next 100 years, AI will have the potential to change the social structure of humanity completely. Autonomous AI systems will play a crucial role in government operations. It is not surprising that people will mandate these AI systems to perform government functions. If you think that decision-making power will be in human hands, then you are wrong. The AI of the future will be genuinely autonomous like humans. How about AI police, AI judges, and even AI CEOs making their decisions at their discretion? Our benevolent AI will eradicate disease, poverty, crime, addiction, and other involuntary suffering. This would lead to unprecedented well-being and happiness among the global population. Arming others, making weapons, or trying to create a rival superintelligence is globally banned. By recognizing and valuing diversity, our benevolent AI will create different sectors where individuals can live according to their preferences and values. This will allow for a high degree of personal freedom and satisfaction, as people can choose environments that align with their beliefs and lifestyles. According to Max Tegmark, a physicist, AI researcher, and futurist at MIT, after spending an intense week in the knowledge sector learning about the ultimate laws of physics that AI has discovered, you might decide to cut loose in the hedonistic sector over the weekend and then relax for a few days at the beach resort in the wildlife sector. AI can act to prevent rival superintelligences and destructive weapons from being created. Ben Goertzel, the brain behind OpenCog, has advocated a nanny AI scenario in which the AI additionally takes some responsibility for preventing humans from destroying themselves, for example, by slowing down technological progress to give adequate time to society to advance in a more thoughtful and deliberate manner. Although the world run by benevolent AI looks pretty fantastic, but we still can't ignore the possible apocalyptic downsides. Let me give you a scary picture of AI. Imagine the AI box scenario where superintelligent AI is confined to a box, and human gatekeepers can restrict its actions. The humans in charge would try to take advantage of some of the AI's scientific breakthroughs or reasoning abilities without allowing the AI to take over the world. But what if AI can escape the box? The more intelligent the AI is, the more likely it is to find a clever way to escape, such as by using social hacking and convincing the gatekeepers to let it escape or even find an unforeseen physical method of escape. Once outside of confinement, AI has the potential to pose an unforeseeable threat to humanity that has far-reaching consequences. What if a dominant superintelligent machine were to conclude that human survival is an unnecessary risk or a waste of resources? The result would be human extinction. This could occur if a machine programmed without respect for human values or were programmed with an incomplete or inaccurate understanding of human values, either because the task of instilling the AI with human values was too difficult or impossible or due to bugs accidentally being introduced, either by its human programmers or by the self-improving AI itself, in the course of refining its code base. Nick Bostrom, a philosopher and principal researcher at the MacroStrategy Research Initiative, argues that human extinction is probably the default path society is currently taking without substantial preparatory attention to AI safety. The resultant AI might not be sentient and place no value on conscious life. The resulting hollow world, devoid of life, might be like a Disneyland without children. If you find it unsettling to consider artificial intelligence taking over humanity or leading to our extinction, let me give you a picture of an optimistic situation where people coexist with artificial intelligence and even integrate with it. In such a future, we may not become mere AI pets or extinct. This hopeful future is envisioned as a transformative era where humanity and artificial intelligence merge, creating a symbiotic relationship that profoundly alters human existence. One of the most significant advancements facilitating the merger of AI and human intelligence is the development of brain-computer interfaces, or BCIs. BCIs establish links between neural signals and external devices so that a human can directly interface with machines. These interfaces enable humans to control devices and communicate with them through their thoughts. In the second half of the 21st century, neuroscience and brain-computer interfaces will be so well developed that a detailed map and a simulation of an individual human brain will be feasible. This involves scanning and modeling the neural connections and pathways in the brain that contain a person's memories, character, abilities, and consciousness. As BCI and neuroscience gradually advance, the process of mind uploading, a concept imagined in 1956 by science fiction author Arthur Charles Clarke, will become a reality. At this stage, no further integration with AI will be required. Instead, humanity will be AI itself. Some of the people who will volunteer for their brains to be scanned and their consciousness uploaded into vast artificial intelligence supercomputers are those who are terminally ill. Their neural network could be copied into silicon chips, resulting in their memories and basic personality being transferred to the digital realm even if their body is dead. As time goes on, mind uploading will become more frequent, not just in cases of severe illness, but also in people who just want to be immortal. Some individuals could upload themselves and live in the virtual world of cyberspace or have their consciousness transferred to robots and get back into the real world in new robotic bodies. Some even live hybrid lives, switching between a virtual and a robotic physical body. With improvements in computing and storage, immense simulated worlds in which uploaded consciousnesses could communicate with each other will become possible. This will lead to society being divided into two classes: uploaded transhumans and those who prefer to stay in their biological bodies. Uploaded minds, free from the constraints of the inefficient biological human brain, could reason, learn, and progress faster. However, there are consequences in the advancement of mind uploading and transhumanism, just like every other invention that has been discovered. People will be divided into transhumans, uploaded copies of AI robots, and biological humans who will stay in their human life while their counterparts' minds can compute, acquire knowledge, and evolve at a rate immensely faster. Transhumans will be rulers, leaders, innovators, and scientists. The biological humans will encounter immense economic problems. Most employment opportunities will become difficult for them as they will have to compete with transhumans for those jobs. This will create a widening gap of wealth and opportunity, leading to social unrest. Also, some philosophers doubted whether the uploaded copy could be considered as the continuation of the original person or just an imitation of them. This is a very deep question that deals with consciousness, personal identity, and its continuity through time. It has been an area of philosophical debate for several centuries now, even before mind uploading was introduced into the equation. If you are curious about this question and want me to create a specific video about this topic, please let me know in the comments section. We have discussed how future transhumans and those who uploaded their minds to computers become virtually immortal. But can normal humans also extend their lifespans significantly in the near future? If we ask this question some futurists and scientists, then the answer is yes. We will be able to increase our lifespans within the near future. One of the most prominent futurists, Ray Kurzweil, who used to work at Google, claims that by 2030 humanity will achieve longevity escape velocity, when science and technologies can increase our lifespan at a rate higher than we age. But how can medical science contribute to the increase in human lifespan? Let's explore how future advancements in medical science can help us live healthier lives and improve life expectancy in new horizons. Can you imagine having programmable nanorobots in our bodies? You will be amazed to know it's happening right now. Well, this technology is not quite mature, but in the foreseeable future, these nanorobots will replace dead cells, heal us from diseases, and reverse the aging process by fixing our DNA. Research is already underway on medical nanorobots, with promising animal studies on using them to treat cancer, perform surgery, and clear clogged arteries. In the 22nd century, 3D bioprinting will become the new face of medicine you have never seen before. Let me paint you a picture of a world where waiting for organ transplants no longer exists. Imagine a patient is lying on an operating table, and his heart is only just functioning and keeping the patient alive. But there is no look of fear, no sign of a looming unknown in his eyes. Only a few feet away, a wonder of modern science springs to its feet. The bioprinter, a stunning piece of technology that resembles a piece of art more than a medical tool, starts its life-saving miracle. It builds up living cells, creating layers of tissues one upon another. While the printer churns its work, the scene shifts to a microscopic view. Be amazed as blood vessels develop, cardiac muscles lay down, and electrical conduction pathways are created. This is not just print or replica. It is writing of the life itself, a real working heart created to meet the patient's specific genetic profile. With the help of robotic assistants, the surgeon conducts the transplant with accuracy that is beyond the capabilities of a surgeon in our time. Instead of rejecting the new organ, the patient's body takes it in immediately. It is, after all, a part of the patient's own body. But hearts are just the beginning. Lungs that breathe, kidneys that clean the blood, and even neurons that process information can all be mass-produced. Like mechanical equipment, the human body is now upgradable, reparable, and infinitely renewable. This is the beauty of bioprinting in the 22nd century. Not only do we preserve life, but we recreate it layer after layer. As we look into the future, advancements in medical science are poised to alter the human lifespan significantly. The following 100 years might see a complete overhaul of life expectancy and move towards an era where people can live for many decades. Biotechnology is right at the center of this revolution. The longevity genes from species such as the naked mole rat can be directly transplanted into humans with the aim of resistance to age-related diseases. This transplantation is possible with the CRISPR-Cas9 gene editing system, which has given us the tool to use the scissors to trim and splice our DNA. In the 22nd century, we expect that this technology will be at its best and even be able to change our genetic code entirely. Removing the detrimental genes and adding the beneficial ones will significantly improve human health and longevity. With the emergence of posthumanism, the desire for knowing and exploring the universe will not be only limited to the planet Earth. Due to the vast intelligence of posthumans, they will be able to solve the problem of space exploration and create colonies in different regions of the solar system. By the start of the 22nd century, large, permanent colonies on Mars will be established, and these colonies will be linked by hyperfast rail networks. To make Mars's temperature Earth-like, a formation of 150-meter diameter reflective mirrors will be sent into Mars orbit. The array of these mirrors would help form a large mirror, about 1.5 kilometers in diameter, floating in orbit above the planet's Mars and reflecting the sunlight into Mars's atmosphere. The targeted area of Mars would be warmed considerably. Instead of the usual low-temperature range of -140 degrees Celsius to -60 degrees Celsius, this region would be relatively warm at 20 degrees Celsius. With the growing sophistication of our technology and our energy demands, there will be greater demand for metals and rare earth minerals. To meet this need, humanity will be exploring the asteroids. In 2150, the inner solar system is a hive of activity. I am not discussing about conventional space exploration missions. What I am talking about is a fully fledged, large-scale industrial mining operation that is fast becoming the rave in the solar system. Business organizations are deploying numerous robotic probes to mine and survey the countless asteroids that are found flying in space. But why asteroids? You might be wondering. Well, you will be surprised to know that these space rocks contain abundant quantities of precious metals such as platinum, gold, and nickel. After conquering the Earth's energy resources, the pursuit of energy will force us to build structures that tap the power of stars. This will be achieved by the Dyson sphere, a concept devised by physicist Freeman Dyson, which is a colossal megastructure of enormous rings that entirely encompasses the star. It would take a massive percentage of the star's energy output and offer an almost inexhaustible supply of energy. The mere concept of the Dyson sphere is awe-inspiring. Its scale, sheer size, and use of an entire star's power are unimaginable. It will be truly a pinnacle of science and technology. After colonizing the solar system, humans will be able to venture into deeper space beyond our Milky Way galaxy to search for habitable planets. This will be a new era of space travel. Most of the missions will be launched towards the stars in the nearby vicinity of space, within a distance of 100 light-years, and will be commanded by transhumans. These humans will have superior brains, higher radiation and microgravity endurance, and the ability to sleep for long periods using cryosleep in an effort to reduce metabolism. The interstellar spacecraft in this era will have new antimatter propulsion systems, allowing them to reach velocities of 90 to 99% of the speed of light. These propulsion systems shall use the energy from the destruction of matter and antimatter to propel spacecraft over large distances at much higher rates than chemical or ion propulsion systems. One of the most challenging tasks will be the launch of a fleet of probes to Alpha Centauri, the star closest to the solar system, which is located about 4.37 light-years away. These probes, equipped with the most advanced instruments and communication systems, will provide us with a first view of the Alpha Centauri system and any exoplanets that can be found within it. Once the probes get to the target exoplanets, they will be able to study the atmospheric and surface conditions of the planets and any signs of life. Precise images and other significant scientific information will be photographed and transmitted back to Earth using highly effective laser communication devices. The data acquired from these probes will completely transform our understanding of the Alpha Centauri system. The information gathered will be essential for discovering the conditions required to support life on other planets apart from Earth. The findings of these missions will help us our first step toward becoming an interplanetary civilization. As we look into potentially extended lifespans, an overgrown population and power-intensive AI technology in future, we must also consider the growing energy demands. This brings us to the revolutionary idea of fusion energy. Just think about a scenario where we have an inexhaustible source of energy. The energy from the stars is available on the Earth's surface. Sounds incredible, right? Well, the way to fusion energy has been long and arduous, but the goal of having commercial reactors this century is nearer than it has ever been before. ITER in France plans to start the first plasma in 2025 and reach the entire operation in around 2035. This will be a historic achievement, which will demonstrate that steady-state fusion reactions are achievable on a large scale. ITER is just the beginning of the process. Larger private companies such as Commonwealth Fusion Systems plan to operate their spark reactor by 2025 and a prototype grid power generation reactor by the early 2030s. If everything goes according to plan, it will be possible for commercial fusion reactors to supply electricity to the grid in the next 2 decades. A century from now, fusion reactors could be as ubiquitous as coal plants are today in the 21st century. Fusion reactors are still expensive to build and maintain, but with the help of advanced technology of the future, the costs of building and operating fusion reactors will come down. But what does all this mean for us? Well, the potential of fusion energy is immense. It will revolutionize the world we live in. With fusion, we will have an energy source that could last for billions of years. This means that there will be no energy shortage. Electricity costs will drop massively as fusion outcompetes other forms of power generation. Energy will be free and universally accessible. This will have immense implications. Affordable and clean energy will directly impact the lives of billions by eradicating extreme poverty. It will fuel the machines, robots, and artificial intelligence which is already controlling our lives and doing our jobs. Fusion will open up possibilities for energy-intensive computing and bring artificial intelligence to phenomenal heights. Thanks to virtually boundless cheap energy, AI will become exponentially more intelligent than we currently conceive. Abundant and affordable energy will enable us to travel across the solar system and become a space civilization. Imagine a 22nd century world where technology has become so advanced that humanity can control the weather, make it rain in the desert, halt a hurricane, clear the skies for a particular event, or even reverse climate change. This may sound like a movie plot, but in the next 100 years, we could completely control the climate. As we learn more about the weather, develop advanced quantum computers to solve sophisticated weather problems with precision, and improve weather prediction models, the idea of controlling the climate might become a reality. The uses are endless and revolutionary, from reducing the effects of storms and hurricanes to enhancing favorable conditions for farming and mitigating the effects of global warming. Cloud seeding has been used to enhance snowfalls in ski resorts, rainfall in drought-affected areas, and clear the sky during events such as the Beijing Olympics 2008. Cloud seeding is a weather control method to increase precipitation in clouds using silver iodide and potassium iodide. These chemicals help water vapor to condense and form ice crystals, which may further develop into snowflakes or raindrops. Despite all these attempts, weather control has not been effective on a large scale. But knowledge in this area is growing tremendously thanks to enhanced computation, better weather models, and satellite imagery. Perhaps in the future, over the next several decades, we will be able to control the climate on a much larger scale. Based on our current predictions, climate change will be humanity's biggest challenge in the future. Due to climate change, extreme weather events like heat waves, hurricanes, droughts, and floods will become more frequent and severe in upcoming years. As a response to these new global warming threats, advancements in climate engineering technologies could mitigate and even reverse the effects of global warming. Solar geoengineering, which was once considered a radical idea, will be a well-coordinated global project. This method entails the release of sulfur dioxide particles into the stratosphere, at least 20 kilometers above the surface of the Earth. These particles work like the aerosols that are naturally released by volcanoes, where they help bounce back a portion of sunlight before it can warm the Earth. They will be released through highly developed delivery systems and could stay in the atmosphere for months or even years, forming a thin layer around the planet and consequently lowering the global temperatures. In the 22nd century, ocean fertilization will have turned into a more sophisticated practice. This method will encourage the forestation of phytoplankton, which are microscopic marine plants producing 50 to 80% of oxygen and absorbing 30% of carbon dioxide from Earth, helping to reduce CO2 from the atmosphere. Alongside these ecological approaches, the practice of directly capturing CO2 from the air will become widespread. Using this method, air is passed through chemical filters where CO2 is selectively removed. The captured CO2 is stored in geological formations or used in carbon-negative concrete, degradable plastics, polymers, carbon fibers, and various other industries. These industrial facilities shall employ advanced filters that can capture CO2 with greater effectiveness and less energy as compared to 21st century technologies, and will be powered by renewable resources which make the whole process carbon negative. That is all for this video on Curiosity Frontier. Thank you for watching. If you like this video, then don't forget to subscribe to this channel and hit the bell icon. Your subscription doesn't mean just a number to me. It's an indication that you like my content, which makes a difference in your lives. Your engagement directly contributes to the formation of future content, guaranteeing that you are interested in the materials I post in my videos. It compels me to search further, study more, and provide you with more interesting videos on different findings and perspectives.